In this example, we're being asked to solve cosine of theta equals -1/2. And in our previous example where we were solving a sine equation, what we're looking to here is to get the infinite set of solutions for this equation. And again, in terms of the unit circle, the question we're being asked here is for what arc lengths or what angles does the cosine have a value of -1/2? The cosine on our unit circle are the x values, so what we're looking for are the points on this unit circle that the angles get us to those points where we have an x value of -1/2. Well, we know that occurs right here. This is -1/2 comma √3/2. And we know it happens down here in the third quadrant. This is -1/2 -√3/2. Those points are pi/3 points. This is 1 pi/3. This is 2 pi/3. That's one of our solutions on one trip around the unit circle. 3 pi/3, and then this is 4 pi/3. But importantly, my goal here is to generalize the process of solving equations with cosine. And I want to talk about a really important property, and it's going to have me talk about this location with a different angle. And importantly, we know that cosine is an even function, which means the cosine of an angle is equal to the cosine of the opposite angle. And why that's important is that that fact gives us a quick way of finding the two spots on the unit circle that solve any equation involving cosine. And what that means is in this case is that if we know that the cosine of 2 pi/3 is -1/2, if we instead went negative 2 pi/3, we would end up at another location that has exactly the same cosine value. So again, if we go 2 pi/3 or -2 pi/3, and again, I'm relating it to this point right here, we know the cosines will be the same, and that should make sense, right? We're making the same arc here and the same arc here. We'll have different y values, but we have exactly the same x values on the unit circle. And with that, then we can describe the infinite solution sets. We have theta, which equals 2 pi/3 plus 2n pi, and again, this n right here is any integer. We also have the other location described by -2 pi/3 plus 2n pi, again, where n is an element of the integers. So this solution set and that explanation about the fact that cosine is an even function gives us a generalized method for solving cosine equations. Importantly to say also is that if this was not a known value, so again, I knew there are spots on the unit circle that have a cosine value of -1/2, but if that was something that wasn't 1/2, like let's say it's 3/7, I could apply the cosine inverse. And importantly, when I apply the cosine inverse function, I'm always going to get out values on this part of the unit circle between 0 and pi. And in this case right here, if I apply actually the cosine inverse to this, the cosine inverse of -1/2 will output this spot right here. Again, in that second quadrant, or more importantly, in the upper half of the unit circle. Well, then I'll simply just use this fact, the fact that cosine is even, to find the second point on the unit circle. And that generalized form of the solution set for a cosine function of this form right here is the set of theta values such that theta equals positive and negative, or plus or minus, cosine inverse of A plus 2n pi. And again, just to relate this back to this statement right here, the cosine inverse of A is going to output a value in the upper half of the unit circle, in this case 2 pi/3. The -2 pi/3 will give us the second part on the unit circle, and these plus 2n pi's, again, are just denoting the fact of these coterminal points and trips around the unit circle at both of these spots. And again, this is two different spots. And again, I needed to note that n is an integer. And again, to reiterate a really important point between the sine equations and cosine equations is we handle them a bit differently because of their symmetry or the identities that we have. In this case right here, since cosine is even, once we use the cosine inverse to find one location, it's simply taking the negative or the opposite of that value. If we have sine, we use the property as previously discussed that sine of theta is equal to sine of pi minus theta. So the difference here is we don't just do a negative theta to find the two solutions for sine. We take whatever we get out from the sine inverse function and we do pi minus that value to get our second point on the unit circle.